Okay, let's do it. Welcome to my talk called Blockchain More Than Bitcoin. I hope you're somewhat interested in cryptocurrencies. Anybody that would call them blockchain, cryptocurrency expert, developer, practitioner, raise your hands. I see 2 hands in the room. Mine is for a reason as well, but we'll get to that in the talk. The idea is, well, what I want to tell you, I want to explain the concepts. And since this is a Java-themed conference, I want to tell you which projects to check out on GitHub if you really want to start something tomorrow, well, Saturday, if you want, or if your boss asks you to build something enterprisey. Because there are solutions like that. At least I know of some. It's obviously not going to cover the entire topic from one to the other side because it's just too broad and too dynamic. With that, my name is Andrzej Grzesik. I have a Twitter, an email, a blog, which is half dead. I'm a Java champion, and as at least most of Polish Java champions, I code mostly in Scala. I am a founder of, well, Kraków Hadoop user group, of Software Craftsmanship Kraków. I'm one of the organizers of GeeCON, so happy birthday to GeeCON. Thanks for being here with us every single year. One of the leaders of Polish Java user group. And also, I live in London. So if you haven't seen me in Kraków or if you haven't seen me around for the past, well, over 5 years now, I've been living there. First working for eBay, then working for a luxury fashion retailer. Then had some time in one of the blockchain startups. And then heard that because I was pair programming, my commit count was not adequate and the complexity of the commits was not adequate, so I have to go. So right now I'm unemployed and it's great. I highly recommend taking a break. In all fairness, it was awkward, but anyway, we wanted to talk about Bitcoin. You've heard of Bitcoin for sure. It's been in the news. It's been crazily expensive, then crazily inexpensive, then even more expensive. I first saw and heard about Bitcoin when it was priced at $3. I thought, no, I have to make a note. I'll buy it later. And then it ended up being 1,000. So I thought, nah, it's too expensive now. That's my story. Anyway, what can you do with Bitcoin? Well, it's easy. With Bitcoin, you can mine. So you can invest an amount of money and an amount of electricity into mining. Is that a reasonable thing to do? I won't tell you that. You can, of course, buy Bitcoins on exchanges. You can transfer them. You can receive them. You can try to, well, hack and exploit the technology because it's the most popular one. You can pay with Bitcoins. And that's pretty much it, I'm afraid. Of course, you can start a business or have a business that's somewhere in the vicinity, like an explorer for transactions, something that tries to anonymize transactions if you want to transfer all your money to, I don't know, one of the political parties and you don't want your friends to know that you did it because how can you support X when you should support Y? There are solutions to do that. But yeah, Bitcoin, very popular, but I would say it's quite limited in what it can do and what you can do with it. So let's look at something else, maybe Ethereum. Luckily for me, Ethereum has been covered at this very conference, I think on Wednesday, in what I believe was an excellent talk, as many of them from Nicholas, called Starting with Ethereum, a Developer Approach. So if you want to explore Ethereum in some more detail, watch the video after. And I'm not going to cross over with that talk too much because, well, I respect your intelligence and memory or ability to use YouTube after we upload. Coming back to our question, what can we do with Bitcoin besides mining and speculation? Well, not really much. But Bitcoin is something interesting. It's a new form of money. A new form of money because obviously it's not backed by any of the central governments. It's not backed by an organization. It's kind of, well, it just happened. That leads me to a question, well, what can we consider money? What properties does something need to have to actually be a useful as money? Well, first, it has to be scarce. By that, I mean if it's something that I can easily create 100 of, and I have 100 of, and I want to pay for a pizza with that 100, but the pizza maker can easily create their own 100, and why would they accept mine? It means that the 100 is worthless, and then you need more, and it needs to be scarce. Scarcity here brings value. It needs to be divisible. So if I have, well, some amount of money, I don't need to trade in the whole amount every single time. That would be slightly inefficient. If you try to use, let's say, a cow as money, cows are divisible, but it's not that easy. And whereas dollars, Polish zloty, is much easier on that front. And they need to be durable. So if you have some amount of money, if it goes away with time, we'll take inflation out of the discussion for now. If the money degrades by itself very quickly, it's not really a good way to store value. Because, well, you need to do it quickly. You need to use it quickly or it's gone, like in South Park. So then, of course, it should be transferable. Cows are transferable. Something else is transferable. You need a way to well, give somebody else the money, because the money, if you don't use it, if you cannot use it, isn't really useful. If it's not useful, it won't represent a lot of value, which means, well, it kind of loses the point of being money in the first place. And the last parameter of money needs to be fungible or interchangeable. You need to be able to, well, I have 50 zlotys, and my 50 zlotys is the same as your 50 zlotys. Unless we are collectors and we actually care about the manufacturing date, the serial numbers, every zlotówka is exactly the same, at least to me. I'm not an expert in numismatics. Same goes for dollars, same goes for pounds. They all look kind of the same. I don't care. The same goes with Bitcoin. One Bitcoin is one Bitcoin. It doesn't matter which Bitcoin you have, unless you see some extra properties in them. Then it's a different story. And that's what we need from money. Those are probably the parameters. Bitcoin has that. Government issued money has that property. Well, government issued money has the funny characteristic. Well, they are scarce, but with an asterisk, because, well, the governments can always print more money. It's not such a super easy process, but some of you, well, might know that governments become very unhappy if you try to take over their monopoly and use your home printer and print something out yourself. If you try to use Photoshop for printing money, well, like $1, it will say, no, you're trying to do something that's not accepted, and it will not work on those images. So, well, there is a monopoly. Bitcoin doesn't have that, but political things aside, another interesting feature of Bitcoin, another feature of that it popularized, is Bitcoin has a distributed ledger. Are you familiar with the concept of a ledger? Do you know what a ledger is? Raise your hands if you do. Okay, let's say a third of the room. So, your developers, maybe let's ask this question in a different way. Do you know of event sourcing? Yeah? Okay, even less hands. So, if you have a bank account, what you're interested in your bank account is the balance. But the balance in your bank account is not a field. That's not how it's represented. Nobody, if they are sane, at least, would store balance of a bank account as an integer, as a field. You would store a stream of transactions, and you would write them down in an append-only, unmodifiable, immutable structure called ledger. Then, after you have such a creation, you are able to calculate the balance by going through the transactions and, well, summing or subtracting the values that, well, or doing anything else if there is any interest to be calculated. Great thing about Bitcoin is the first technology that massively popularized a distributed ledger. So if I want to start Bitcoin on my computer, if I want to start it on somewhere else, if you do it, any of you, well, you will have the copy of the entire ledger. And if you want to add something to some nodes, eventual consistency, those transactions will be popularized to all the nodes everywhere. Which means, of course, it's going to take a lot of space on everybody's machine. And it's going to be expensive. Not in the form of it's going to cost a lot of money to do it, but expensive in the energy that needs to be spent. You might have heard about mining. Well, did you hear about mining of Bitcoins or other coins? Yeah, good. I can share something. Not that I believe in Ethereum as a cryptocurrency. That's absolutely great, but I use Ethereum to heat one of the rooms in my house. It's cheaper than British gas. Current economies. I'm not saying it's a great idea or it will work in your particular scenario. It just works for me at the moment, at least. Bitcoin network, Bitcoin as the concept, well, it needs miners to operate. It compensates miners for their efforts in validating blocks of transactions by releasing Bitcoins. Well, nobody does it on their own anymore. People join themselves in pools because you need a lot of computing power, as in a lot. If you ever Google Bitcoin mining facility, you will be surprised at how industrialized those operations are. But anyway, what it means is for Bitcoin to operate, a lot of people need to spend a lot of energy, which is estimated to be around the usage of Iceland or maybe more at the moment. It also produces a lot of heat. Hence, again, Iceland, great place for mining because it's just cool there. Probably Svalbard would be good as well, but it's just harder to get Bitcoin miners to Svalbard than anything else. And so Bitcoin operates, well, people mine, people get Bitcoins, and there is 12.5 Bitcoins for released for every block that's completed. That gets shared across the people who are part of the pool that mines. And that means that new Bitcoins are released into the wild all the time. Well, right now, I think around 17 million of Bitcoins have been released, and there is a software limit, a hard software limit of 21 million of Bitcoins to be ever produced. There will never be more, unless the assumptions that we are operating under change, and that will be an interesting time when that happens. But let's not go there further because that's too much Bitcoin. What I'm more interested in is blockchain or a distributed ledger. We are all programmers, or most of us are programmers here, so you can look at blockchain as a list of hashes that point to blocks of transactions. That's what I try to depict here. Bitcoin uses that concept, Ethereum uses that concept, so many other things use that concept. It's basically multiple linked lists with one node, well, the current node, the one that you're appending to, pointing to the previous, to the previous, to the previous. So if you want to rewrite history, it's difficult because you don't modify the history, which is a good and a bad property, depends on how you look at it. Which means blockchain, any blockchain, is a distributed data store. Eventually, it will populate itself. Eventually, it will be everywhere. And there is a funny thing. Bitcoins, specifically blockchain, is constantly growing in size. At the moment, you can see how many megabytes, but it's sizable. You can see the trend. It's looking exponential to me, at least from here, which means you can imagine the future in which to be able to have a complete view of what's happening with Bitcoins, you'll need not just one SSD, but a lot of them. Somebody could say that Bitcoin and their blockchain could be a plot by the hard drive manufacturers just for people to buy faster drives, but that's just a side effect of Bitcoin being popular. As you transact, you add them you add your transactions to the ledger. Ledger grows because it doesn't shrink in any way, and it's immutable and it's append only. Once a transaction gets in, it's always in, which also leads to very interesting problems. Every Bitcoin transaction has around 40 bytes or 40 bytes of metadata available for your creativity. Imagine somebody wants to put a picture, a formula, I don't know, a text that's considered to be illegal by some jurisdiction. Does it mean that you cannot use Bitcoin in that country, that you shouldn't have those transactions in your blockchain, that you should never have the blockchain? I don't know. There isn't a good answer. It's just a problem at the moment. Imagine somebody puts some minor related graphic content in parts or just links as metadata, and then that might be completely illegal. Let's say in one of the countries. The US actually has a law, or is discussing a law at the moment, which prohibits people from transmitting child pornography in any way. ISPs, for them it would be legal, even if you don't know what you're doing, or even if you're unaware that this is happening. That also by effect means that would be illegal to run a Bitcoin network or have the complete blockchain in the US if that goes through. We, as software engineers, have solved that problem already. Well, event sourcing, which I asked about earlier, has a concept of snapshots, which means you don't need to look at all of the transactions since the beginning of time every single time. You can actually calculate the state at a given time and say transactions up to, let's say, transaction number 1,000,000 result in this state of the network. And then if you want to calculate that again, you can, of course, do that, but you don't have to. So you save time and you save space in terms of storage. There is an excellent article about event sourcing as a concept on Martin Fowler's webpage. There is also a huge number of presentations about the concept, or we can talk about it later. Moving on. I said that Bitcoin is a pretty boring thing. Why do I say that? Because Bitcoin and Bitcoin's blockchain only allows people to transfer Bitcoins. What if I want to do, I don't know, a transfer of a car? Or if I want to represent insurance contracts, or I want to represent GeeCoins, if you remember such a thing, or I don't know, anything else. Chairs in a cinema could be a thing that you could want to trade on a blockchain, or just represent because you want to build a system. Other blockchains, other technologies allow for that. Ethereum does. Some other tech, which we'll get towards further down the talk, allow for that. So that's one crucial thing. If you're looking for a solution, have an ability to represent something else. Another thing is, well, smart contracts. You might have heard of smart contracts. Smart contracts are nothing else but a piece of code or a piece of logic that executes automatically on the blockchain. If somebody does a transaction that falls under the smart contract, that means that, well, it will get executed every single time this transaction happens. This, of course, combined with immutability, produces some interesting challenges for software developers. I, for one, can say that I have not written code that is completely bug-free. But now if you look at a blockchain that's, let's say, one that becomes popular and massively adopted, somebody puts a smart contract early on, and this will get executed forever. It's a very strong assumption and a very dangerous one, if you ask me. So I would be extremely cautious and a bit afraid to write some contracts, well, some that can contain any bugs or that rely on an outside state. But we'll get to there again. And then one more term that I need to mention with the subject is ICOs, or initial coin offerings. There is a lot of Bitcoin blockchain-related technologies out there. There is a lot of organizations that try to have their own assets, to try to popularize their own currencies. You might have heard of Ripple. We already mentioned Ethereum. We already mentioned Bitcoin. There is Monero. It's a lot of them. I would not be able to give you a complete list because I haven't seen a complete list ever. But what are ICOs? ICOs are when there is an organization that usually would seek funding through investors. Instead, now, because blockchain is such a hyped technology, they would try to come up with a technology with their own token, so something like Bitcoin but their own, and they would sell this token in huge amounts in exchange for real money, so that you as an early investor can hope that their technology will succeed, and you're the early investors, and then you become richer, hopefully. And with that, we can take a slight shift, because I'm talking to you about tech. We haven't answered the important question of why. Why would I even bother? Why should we have two talks about blockchain and those talks, those kind of tech at GeeCON. Does it make sense? Well, let's look at how people interact and how they process information and what happens, how we, the systems that we create, transfer state. Well, we have actors in two organizations, or we have two organizations. We might have just two systems. Person on the left does some action. Let's say they go speeding, they get a ticket. That ticket needs to get processed. There is a lot of paper involved. There is probably Poczta Polska or Royal Mail or your favorite fail-proof, not really, slow carrier of choice. Then the same kind of processing, well, a similar kind of manual processing needs to happen on the other side. Perception of the person needs to change, and you need to realize that whatever information you have received requires you to take an action, and then you will probably take that action. The whole process, because it's so protein-based, will take a lot of time. As I say, it's often protein-based, which means humans are involved. Humans are slow compared to computers in repeatable processes. They are also error-prone. You might have gone to a very good party the day before. You might have gone holidays. You might have a jet lag. All things might happen, which means this mode of operation is slow, and everybody's so much happier if they can automate it somehow with computers, which means we go to this great state in which we are migrating right now, especially in this country. Well, you know how dealing with offices was 10 years ago or 5 years ago. All manual, all on paper. Now, finally, we can do something with computers, which means people will use interesting modern technologies like SOAP, like REST, and do it over the internet. Your software people, you know of that. I don't have to explain that to you. But that comes at a price. If you work for any sizable organization, the question is, how many data stores does your organization have? If you think about the systems, my story from a retail company, there is the POS system, so what people have in the stores. Different geographies will have different databases. There is the email marketing system, there is the data lake in Hadoop, there is the e-commerce system, actually in a few copies because different geographies require for legal reasons different data sets, they need to be separate. The data gets copied over and over and over. And that leads to interesting problems. Well, somebody could say, well, is there anything wrong with that? What's the problem? Well, of course, duplicated data. If I have the same data in 17 systems, I need to copy them over 17 times. Storage, inefficient. Governance, inefficient. Things might happen when I'm copying the whole data set from one system to the other because the schema might not match for some records. I might end up with two almost similar copies. Almost, but devil's in the detail. Storage costs, we mentioned that. Latency, because I need to copy this data over and over. It takes time for this data to become available in the same shape and form in all the systems. Double spend or double booking. It's a very important problem if you're selling something there is only one of that. But if you want to put one on Allegro, if you want to put one on eBay, there isn't a good way for you to do that because Allegro doesn't talk to eBay. As in, I am not aware of an integration between them. So you need probably to have two or just try to sell it on one place, then try to sell it on the other place. Then if you want to sell it on Amazon, I have no idea what the integration would look like. But because you have many systems, you need to do strange things about how you assign quantities of items to those systems, if they are to govern those items. If you have an e-commerce store and if you have a physical store, if the software is not integrated, if the software is not using a single warehouse database, you will need to have two stocks, one for the e-commerce, one for the brick and mortar. And that means duplication, that means complexities in the process. So here comes the huge promise or huge hope that blockchain and all the technologies are going to provide. First of all, I will be able to take actions based on facts that are shared with other people. So if we, between each other, between the systems, rely on a blockchain-based solution that actually shares the data from between us, that means that we operate on the same data set. There is only one copy. The problems of latency, not towards perfection, but they become good enough that all the systems operate on the same kind of data. If one wants to modify that, that change is immediately or almost immediately visible by everybody else participating. There is no views of truth that different people decide upon. And in theory, it all becomes just great. Blockchain will be distributed. Yes, we know that because, well, different people, different entities will have their own copies. It will be immutable because, again, you do append only. And as of now, at least with Bitcoin, it's transparent. And that transparency is a bit of a problem. We talked about, well, again, political support is a useful example here. If I want to support one of the presidential candidates in Poland, if there is a next election, do I want all my friends to know that I have sympathies towards candidate X and not Y? Do I want everybody else to know that I went to a pharmacy that is next to a specific place? You can infer things by metadata. You can infer things by knowing that, well, I spent some money in a liquor store. What did I buy there? If I buy a lot of that, you can infer that maybe I'm an alcoholic or something else. Same goes for any kind of shops. Also, if somebody is rich, it's absolutely evident if all the transactions are completely open to absolutely everyone. If you now take the lens of an enterprise, they want to share some data with their suppliers, but not all. They don't want their suppliers to know everybody else who is their supplier, most probably. If you're a big software company, you want to sell to others, but you might not want all of the others to know who is actually using the software. It might be a trade secret, which means blockchain needs some modifications to enable that. Also, for legal reasons, having a complete ledger might be difficult. We discussed that already. So people are excited. Why? Because blockchain, one of the promises is you can get truly atomic transactions across organizations without having triple, four, quadruple phased commits and, well, shared data sets that are actually shared and people see the same view of truth. That's going to simplify a lot of systems. That's going to axe a lot of systems. That's going to, of course, create a lot of development opportunities. So much that I tried to look for all of the companies that are doing blockchain-related tech on the internet. I found a picture. This one is from the year 2015, and this is just in finance. What you should get from that, it's a lot of them. I don't ask you to look for particular logos. It's just a lot of companies, and this is 2015. Now we have 2018. The number of companies is probably quadrupled, probably, or even more. And here comes an answer. Well, if you want to do something blockchain related on the JVM today, which one should you use? I would say, out of my experience with the technologies I've personally worked with, I would say try to have a look at Corda. It's something that doesn't really do blockchains the way Bitcoin does. It does an append-only distributed ledger. It is a distributed ledger. It does have permissions inside. It is JVM-based and is open source. So all looks good. But why I like it so much, or why I think it's a reasonable idea or the most reasonable approach I have seen so far, is because, well, they consider things called networks. If, again, a lot of companies, a lot of suppliers, a lot of providers want to share some information, well, they will need to, well, have a number of nodes, have a shared blockchain between them. But if those, well, some set of companies wants to talk to each other, and then there is the same need but between some other set of companies, does it mean that you need to have two separate blockchains between them? I would say that this is becoming a geometrical problem. It's inefficient, it's unmaintainable. You would end up with having a gazillion blockchains running in the world. And sometimes you will have that. You will have more than one blockchain, but having all of them separately between every single two companies sometimes that cooperate, it's not going to work. So what Corda tries to do is, well, they try to do They try to do something like that, so you can have more peer-to-peer interactions. If your nodes need to know about some other nodes, well, if they transact in some way, they will know about themselves. If some nodes are public, they will know about themselves. If they don't, they won't. That, of course, comes with some other requirements, like privacy. If we are on the same network, should I know about everybody else that's part of that network? Well, the operator of the node should decide. So some of the solutions that enterprises are using at the moment, just some, because remember the slide I've shown you a lot of pictures. There is Hyperledger Fabric, and there is Corda, and again, it's just my personal experience. Corda is a Java JVM-based solution. Hyperledger Fabric, well, Ethereum. You've seen, for those of you who have seen Nicolas's presentation, the software is not written in Java. You don't write the contracts in Java. I like Java as a platform. I'm just happier there. I'm more productive. So I would say, let's look at Corda in a second. And those platforms, well, the Ethereum are going to be against some of the challenges. Some challenges which are, some of them are secrecy. If I want to do something I don't want, Shimon, who is enjoying the first row very much, I don't want him to know. Well, why in the world that's where everything is absolutely public, that should it's hard to hide. You can, on let's say the Bitcoin network, you can ask some services to anonymize your transactions. What they will do is one of the ways is to spread out your transaction into multiple different tiny transactions, and then a swarm of transactions will go somewhere else, and then you will create some artificial traffic and try to hide in a sea of the normal Bitcoin noise, let's say. But this is opportunistic, and sometimes there are legal reasons that actually require you for things not to be even available. And I don't know what the GDPR's effect will be on that. So secrecy is a huge problem. You can, of course, encrypt and encrypt again and encrypt again, or you can just have multiple networks between parties that shouldn't know about themselves. But this is inefficient. This is multiplying entities beyond need. Another challenge is having multiple blockchains, because if you have some companies working together and they already have some blockchains, and then some other set of companies wants to start trading, then you will have the copy of copying data between blockchains. And you know what happens then. This is exactly the same situation that we are in right now with databases. It doesn't matter whether you copy data between a MySQL to an Oracle and through a Cassandra, or if you do it from one Ethereum blockchain to a Hyperledger Fabric to something else. Same problem. Logically, there are multiple entities, which means there is a logical incentive to have just one network so that things as entities are represented only once. That leads to an interesting challenge of who can I trust? In the world of Bitcoin, you don't get that choice. Anybody can transact with absolutely anybody else, which means you can hope that people don't make mistakes. You can hope that people are who they claim to be and that they are not malicious. That might change. That might not be the true. You never know. Or you don't have a way of guaranteeing that you know. And there is another problem that Bitcoin doesn't solve because it uses Bitcoins. But if you have multiple kinds of assets operating on a ledger, let's say I'm exchanging money. I want to give someone 100 euros and somebody wants to give me for that 100 pounds or dollars, and the rest should be paid back in some other form. Question is, what is the exchange rate? How should we do it? I can assume the exchange rate is favorable to me. The other person can assume it's favorable to them. Third parties usually provide that information. When do we get that information from a third party? Which third party? At what time? We should have a way of agreeing what third party, which third party, on what conditions do we ask for additional information. So those third parties are useful. Corda solves that problem with notaries, but yeah, it's another problem there. So if you want to try Corda, you can go to Corda.net. I know you know how to run through a bunch of tutorials, so we will not do that. But I wanted to show you some code, and I wanted to clone my display, but that seems better. No, you shouldn't see that. So, this is a cinema, which makes my life so much easier because I don't have to ask if the code is big enough. Well, this presentation mode here. Now the code is even bigger. What I wanted to show you is a smart contract looking what it looks like in Corda. So you can see the code is in Kotlin. If you have tried Kotlin, you know what to think. If you haven't tried Kotlin but are still stuck in Java, I would encourage you to try Kotlin. You can, of course, decide that, well, you might want to write everything in Scala. Anyway, bottom line with Corda, it's running on the JVM, which means all of your libraries or all of your knowledge, that's safe to stay. Here, we can see that we'll not get into the details of what those entities in particular really are. If you get to try it, or if you want to talk after, we can. The important thing that we do is we have a flow, which means a long-running operation, a saga, if you want, that has some stages. Well, you create an IOU. It's an indication of somebody owes somebody else some amount of something. That's it. You build that. You create an output state and add a command. That's, again, Corda-specific language. We won't go there. What you can see is you have a progress tracker and you have steps. The thing that I didn't mention about smart contracts is they might take an arbitrary amount of time to execute. Same in case of this one. Because imagine a scenario in which I create a mention, an expression that means, I don't know, Pavel owes me money, and I owe money to, I don't know, to Maria. And because of that, well, there needs to be some interest accrued on some date, and this is the contract. The interest will get accrued every single time a particular amount of time happens or passes, and this should happen indefinitely until this gets paid back. Which means this will keep running potentially for years if I'm a very bad person and never return my money. Which means you cannot think about it. Well, you can think about this is code as you know it, but the runtime is not just going to go stage by stage by stage by stage, because it can't. So what you see here is an interesting concept of a subflow. And this subflow is something, well, if you want somebody else to do something, or if you want to wait for them to do something, you can use it. You can do it with subflows here. There is no indication of the amount of time that passes between those two stages, or actually any of the stages that you have in here. This can run for an indefinite amount of time, which is the third interesting thing about Corda that I didn't mention on the slide before. It includes a flow language or a flow mechanism, something that allows code to run for some amount of time and progress step by step whenever it's possible. And this can be a very long-running process. If you have a smart contract that just operates on data in the blockchain, this is trivial. Life is easy because everything is accessible digitally. But imagine you have a contract that asks for somebody else to acknowledge a shipment arriving at a warehouse. This is something that's obviously going to take a few days because you need the goods to physically materialize. You know what courier services, what their legendary quality is. I think every country gets the same amount of problems with them. It's a thing that takes time measured in days, not in milliseconds or seconds, which means this has to be somehow stored on the blockchain And smart contracts, like in Ethereum, will be stored on the blockchain. But the place where Corda is slightly more interesting than others is they have a mechanism to acknowledge that the contract that you have created has a bug. So you can migrate, you can upgrade your contracts. And that means when you discover that, well, reality changed, legal system changed, I don't know, VAT amounts changed, you can make code reflect that. And I think this is a good time to ask if you have any questions or if you'd like to ask for absolutely anything about blockchain, because we still have a few minutes, because this was a lot of new things to you, and I don't want to kill you with information. So, any questions? Raise your hands. We have a microphone available. We can walk up, or if your screaming is good enough, I'll try to hear you. Repeat the question and, well, hopefully answer. Or we can just finish and we can talk in here in private if you prefer. There is a question. Kuba, good.
Hi.
Hi.
The question is, because here you're using Kotlin. I've seen that a lot of blockchain stuff is done in Solidity.
Yes.
So what's the idea of using Solidity? Why should we even think about that? Or can we stick to the JVM languages?
So people are using Solidity if they are writing code on Ethereum. If you want to code on Ethereum VM, you don't get a choice of writing anything with anything else than Solidity. The Corda is a separate technology. It's like Ethereum, but different, a completely separate thing. That's why it allows you to use Java and JVM languages. So if you want to do that in Scala, you're welcome. If you want Groovy, you're welcome. There is a Java API, there is a Kotlin API for that. That's why I'm showing this at a Java conference. It's the most relevant blockchain tech I could find as of today, or as of yesterday. Anybody else? Okay, I don't see any more questions. So I have to say thank you very much for being here. Thank you very much for listening to this talk. Enjoy the rest of GeeCON. Bye.